Hello. This program will give you multiplication of two 8-bit numbers. So first we will see multiplication of two 8-bit numbers. Then we will try to multiply 16-bit number with an 8-bit number. Then we will multiply two 16-bit numbers. So the logic for multiplying two 8-bit numbers is very simple. Here we make use of MUL instruction. By default, the syntax for MUL instruction is MUL AB. This is the syntax by default. So whatever data I need to multiply should be in accumulator and register B. We cannot multiply other than accumulator and B register. So we should keep in mind, if at all we are performing multiplication of two datas, one data should be in accumulator and the other data should be in register B. Accumulator will be multiplied by B register. After multiplication, we may get the result more than 8 bits. If we multiply MULAB, the products which will be more than 8 bits will be stored in accumulator as well as B register, where lower order result will be stored in accumulator and higher byte of the result will be stored in register B. We copy from register A and we copy from register B and we transfer to wherever the data is required to be shifted. This is the concept here. We can use 8-bit memory or 16-bit memory for this multiplication operation. In this program, I have used 16-bit memory, that is external memory, where the data to be multiplied, that is the two 8-bit numbers to be multiplied, are stored in memory location 8500 and one more data is stored in 8501. So the first data is stored in 8500. It is pointed by DPTR. So this instruction will load DPTR with 8500 and the content of DPTR, that is 8500, our first data will be copied to accumulator and that data is saved in register B. Now I can say that first data to be multiplied is stored in register B. Increment DPTR now. DPTR will now point to 8501. The content of that memory location 8501 is copied to accumulator. Now we have both the data, first data in register B, second data in register A. We multiply. Once we multiply, lower order result will be stored in accumulator, higher order result will be stored in register B. So this is the program for multiplication till here. The rest of the program will explain where are we storing the result. In this program, we are storing the result in memory location 8502 and 8503. So what we do here is the content of accumulator which has the lower byte of the AND result is copied to accumulator. From accumulator it is transferred to DPTR, where DPTR is pointing to memory location 8502. Then the data present in B register is copied to accumulator. From accumulator we are incrementing DPTR and we are transferring the result to memory location 8503. So this is the logic of the program. And the same program we execute in Keil Microvision software, and we will cross-check the result. So this is the program for multiplication of two 8-bit numbers. The same program has been written here, where we are performing multiplication of two 8-bit numbers. So this is the program for multiplication of two 8-bit numbers. The same program is copied here to avoid the time. If we type, it will take time. So in order to be very efficient, we have taken the same program here. We save the program. Then we build the procedure, whatever is there for execution of the program is followed. Then we start debug session. So the program has been debugged and no errors are found. Here we have seen that we get input at memory location 8500. So I give input data at memory location 8500. Let me take simple data first, that is I consider 03 multiplied with 03. This is the input what I have given. I run the program. I should get result as 09. Yes, we got the result as 09 here. We can observe. This is the result what we got. We got as 09. We have cross-checked the result. Let us go for another multiplication. Let me multiply the maximum 8-bit number, that is FF. I multiply FF with FF. What should be the result if we multiply the maximum 8-bit number FF with FF? Let us see the result here. We get 01 FE, where FE is the lower byte of the result, 01 is the higher byte of the result. We can execute the program with single step execution. In single step execution, this will give us what happens to the each instruction. What happens when move DPTR instruction is executed? What happens to the next instruction, that is move B, A is executed? Here we can check the result individually for all the registers: accumulator, B register, data pointer, program pointer, as well as we can check which are all the flags affected in PSW. Now this is the program for finding multiplication of two 8-bit numbers. Thank you.